And then what you'll be looking at in today's lab is enzymatic browning. So in this lab, there's these phenolic compounds in fruit that reacts with this enzyme, and that makes the enzyme, that converts these phenolic compounds into a different color as well as a different flavor. Okay, so we know that enzymes are proteins. Protein consists of amino acid. Amino acids have acid and basic properties, so that's why we were looking at buffers and how buffers work. Okay, so here's some more detail about enzymatic browning. So the browning reaction occurs when the fruit tissue is cut or peeled. The enzyme is polyphenol oxidase, that's abbreviated PPO. When that enzyme is released, it reacts in the presence of air with those phenolic compounds and oxidizes those phenolic compounds. So here's the reaction here. So here's the phenolic compound. Here's the benzene ring. There's an alcohol group. Here's an R group. So this is just an alkyl group. Could be some hydrocarbon chain. Reacts with the enzyme PPO and oxygen to produce this compound here. So note that what it's doing is it's adding another alcohol functional group. These two compounds are colorless. This compound reacts with more of the enzyme in the presence of oxygen, and that produces, this is called a quinone compound. So this quinone compound, this is a colored compound, and then this compound can react with amino acids and proteins in the fruit, and this produces these complex brown polymers. And so this compound, these quinones and these brown polymers, which produces the brown color in the fruit. So what you want to do today is prevent this reaction from occurring. Either this reaction or the second reaction or the third reaction from occurring. So how can you prevent fruit from turning brown? Yeah, one way to take away the oxygen. How would you take away the oxygen? Yeah, put it in a bag. What's another way to prevent the fruit from turning brown? Now, what does refrigeration do? It slows down the reaction. So, if lowering the temperature slows down the reaction, what about raising the temperature? Yeah, that's going to speed it up. But do enzymes work under a specific temperature range? Yeah. So, if you're above or below that temperature range, that should inactivate the enzymes. So, for example, another way to do it is to blanch the fruit and put it in boiling water. That's that blanching process. What's another way to prevent fruit from turning brown? Eating it. Pardon? Yeah, eating it. Yeah, using lemon. So what does lemon do? Yeah, lowers the pH. So note that enzymes are acids and bases, and enzymes can also be used as buffers. This means that enzymes work under certain pH conditions or a certain pH range. So if you use lemon, is that going to raise or lower the pH? It lowers the pH. So what the lemon does, it lowers the pH below the pH at which the enzyme is active. Okay. Is there any other ways you can do that? Inactivate the enzyme?
Could you freeze it?
Yeah, freeze it.
Can you soak it in water too?
Yeah, soak in water. What is that going to do?
Sealing.
Yeah, sealing. That prevents O2 from reacting. Okay. So anyway, those are some ways that you can prevent fruit from browning. Now, what you want to look up is what the pH of an apple and a banana are. Should we do that now, or do you guys want to do that now? Now?
Yeah, that clock's been broken.
Okay, so let's take a look now. So let's see.
Just the text. I want to go. I think I should.
Okay, so this is from this engineering toolbox website. So for an apple has a pH, let's see here, between 3.3 and 3.9. And I'm not sure if this applies to all apples, whether they're like Granny Smith or Golden Delicious or Gala apples, whatever it is, 3.3, 3.9. And then for bananas, 4.5 to 5.2. And as we go down this list, it looks like all the fruit, all the produce we're seeing here are all acidic. So are there any basic food products in here? Let's see. See any basic compounds? Cod liver, 6.2. Oh, coconut milk. Well, coconut, 5.5 to 7.8. Corn.
There you go.
Eggs.
Fresh eggs. Eel.
Okay, so here's lemon. So no, lemon has a pH 2.2 to 2.4. We'll be looking at milk, doing a milk lab later on the semester. Actually, we'll do that next week. So milk has a pH between 6.4 and 6.8. Yeah, we'll talk about that next week. It turns out that there's quite a few substances of milk, and we'll look at the substances of milk which make it an acid. Okay, so let's see, we have, so most of these food products are acidic substances. Yeah, this can't be right. Tea is usually acidic. Yeah, the 7.2, right? Okay, so there's some pH of foods. I've got these slides posted on the Chem1B website, so you can take a look at that later if you want to. What is the pH of the fruit rounding enzyme? So let's, how do we get out of safe reading? Okay, we'll look up the let's see, pH of, let's see if that's here. Yeah, so here's the polyphenol oxidase. Oh, so let's see what's in here. Oh, I don't want to read this piece. I don't want to read that piece. Let's take a look at, let's see. If I can figure out how to. Here we go.
Mr. Yee, right there.
It wasn't working. There's some thing enabled. See, all you get is that.
Unhighlighted and re-highlighted.
It did. I was highlighting it and doing this other stuff.
Maybe just use the yellow thing.
See, there's all the security stuff on here. Okay. Worthington, Biochem. phenolic compound, and here's the quinone which forms. So this is the colorless compound, this is the colored compound. So it says in here that, let's see, polyphenol oxidase is a bifunctional copper-containing oxidase. Oxidase is an enzyme having both catechol and cresolase activity. Okay, so catechol is this catechol is this one, cresol is this compound. And let's see here. They're saying that the optimum pH of polyphenol oxidase from mushroom is between 6 and 7. Now, I think this only applies to mushroom.
What is it for apple?
Let's see. So you're saying what is it for apple? PPO and pH of let's see. Just looking at that one. Okay, here's one. If you want to believe answers.yahoo.com, let's see. So the best answer chosen by the voters was a website. Okay, we found that already. Okay, so anyway, maybe it's between, looks like the best answer we've seen so far is between 6 and 7. Okay. Now let's answer this question, because this will help us in the lab when you're using those buffers to see if you can prevent the fruit from turning brown. If the fruit browning enzyme is active at the same pH as the apple, what color will the apple be? Why brown? Yeah, so like Samson says, the apple should be brown because the pH of the apple is the same as the pH of the enzyme, which means that the pH is working. The enzyme is working at that pH. Okay. So, do you think like a pH 5 or 6 buffer will work to prevent the apple or your banana from turning brown?
They're about that, right? pH of apples and bananas.
Now we said that according to that website, the pH at which this enzyme is active is between 6 and 7. So if you use a pH 6 buffer, will that prevent the apple from turning brown?
No.
So if you use a pH 8 buffer, will that prevent the apple from turning brown? Yeah, so hopefully it will. So we'll see if that works in lab this afternoon. Do fruits or vegetables that contain vitamin C turn brown? Now, vitamin C is an antioxidant, and what's happening in this reaction is an oxidation-reduction reaction. Okay, so antioxidant means, what does vitamin C do? It will... Yeah, it prevents things. In other words, vitamin C will oxidize something else. Okay, rather than rather than oxidizing what could be oxidizing. Okay. So if you put vitamin C on fruit, is the vitamin C going to help it turn brown or prevent it from turning brown? So it would... Yeah, so if vitamin C is an antioxidant, we expect that the vitamin C would prevent or not prevent. Yeah, we expect it to prevent the fruit from turning brown. So you'll actually try that in lab too. Use as one of your experiments vitamin C to see how that works. Okay. Okay. Here's some references for all these fruit browning reactions, which you can take a look at if you want to. Now again, we looked at these titration curves. And let's see if we can do a few practice problems again. So this is actually involving a monoprotic acid. You have 20 milliliters of 0.1 molar aspirin That's titrated with 0.1 molar sodium hydroxide. Calculate the pH at the starting point, halfway point, and at the end point. Draw a titration curve for the titration of aspirin with sodium hydroxide. And then we want to figure out, based on the titration curve, at what pH can aspirin be used as a buffer.